Hello everyone, this is the next part of tutorial videos dedicated to inventory system, and in the last part we finished a visual representation of an items that we are adding to our inventory, and I've changed a few things like I've changed fonts a little bit and decreased the size of some items. So first things that we're gonna do now is we're gonna create a normal way to show an inventory. So open your component for an inventory, and I'm gonna move our debug key. You can use input action whenever you need. I'm gonna use input action open EA inventory here, and on started I'm gonna create a widget and show an inventory if it is not shown. So what I have to do, we have to promote our inventory widget to a variable. Let's call it inventory widget. Let's make a category UI, and we're adding it to a viewport. Here we're gonna check if an inventory widget is valid. Just drag it here, right click on it, convert to validate get. And if it is not valid, then we're creating and showing it. In another case, we are remove from parent, and setting it to none. Also, you maybe notice that we are able to move, rotate camera and so on while our widget is on a screen, so we have to disable such possibility. So when we're showing a widget, we have to get player controller, or like we're gonna get character, get player, get controller, and set mode to set game and, well, set UI only. Set input mode UI only for widget, so that everything that we're touching on the keyboard and mouse are handled by user interface and not our character or our character controller. Okay, get player controller. And we have to show mouse, well, mouse cursor. Mouse, set mouse, no. Cursor, set mouse cursor. Set show mouse cursor to true on our player controller. Now let's copy it, paste it here. Every time that we are removing a widget, we have to get player controller and set mode game only. And show mouse cursor to false. So now we are able, okay, I'm gonna remove my old component. Where is it? So now, well, what happens? What's it? Oh, also I'm having this event here. I'm gonna remove it. So now on I we're shown an inventory, but as you can see, we cannot close it. We're unable to close the widget by pressing I again. That's because our component doesn't handle I keyboard button now, and I keyboard button is handled by our widget. So let's change it. Let's open our Webby inventory, open graph, functions, find on preview key down. Here we're gonna get key and check if it was I, for example. In my case, I'm pressing I, or maybe I can. So we're checking if key was I, and if it is true, then we're gonna get inventory system and call some function to close an inventory. Like, what if we copy this or cut this, create custom event and call it toggle inventory visibility. Paste it here. And here on started, we're gonna call toggle inventory visibility like this. Compile, save, and in our widget, if it was I, then we're gonna get inventory system and call toggle inventory visibility. After that, we're gonna return that we have handled this event. In another case, we're gonna duplicate return node, and instead of handled, we're telling that we don't know what was the keyboard button that we pressed, and we were not able to handle this event, so we're returning unhandled. Now nothing is happening because we don't know where is the focus. So open designer, select a widget, search for focus, make a widget focusable, and in event graph on initialized, call set focus. So this widget will be focused and will answer the events. So now we can show and close our inventory, and we cannot do anything with our character. Also, our blur has some paddings. I don't like them. Let's take a look. Blur, remove all paddings from blur. Okay, let's open our VB container item, for example, Apple. And let's add a border behind an image. Let's, I'm not sure, color and opacity. Okay, let's add a border behind everything in the overlay. Horizontal and vertical alignments should be fill horizontal and vertically, and let's call it B background border. Make it a variable and set brush color to 0. Compile and save. So let's override a few functions like on mouse enter and override on mouse leave. So if mouse entered our widget, let's get our background border and set color, set content color and opacity to something like like this. Duplicate it, and in case of leaving, we're gonna set it to 0. Compile, save. Let's check. Nothing happens because this widget is also not focusable, I think. Where is it? here it is. Select a widget and make it focusable. No, nothing happens. Container item. On mouse enter. The breakpoint. At the breakpoint. On focus. Well, everything is cold, by the way, but maybe we don't even need the focus here because we don't handle any keyboard events. But nothing is changed, so background border color is not changed. Let me select an image. Ground border. Oh, we changed brush color and not color and opacity. So let's open here and instead of set content color and opacity, set brush color. So if we're hovering it, then we're gonna use something like this. And in another case, we're gonna use this. Compile, save. So now you can see that an item that we're hovering is a little bit highlighted. Let's make our image opaque again. Okay, well, now we have only secret pocket, but I think that we should have something more interesting with more interesting layout of cells. At least we have to test if it works. So let's open an inventory component, and here in items we have only our secret pocket. Well, now for example, let's add something like where we are adding secret pocket. Here we are adding a secret pocket. Let's duplicate it and let's add a sequence here. Then and after adding a secret pocket, we're gonna add something like, I'm not sure. Let's call it debug pocket. Well, how much items will it have? Oh, no, that's a cell construction. So first, here we are creating our container item. Let's call it debug pocket. It will have 3 rows, 1, 2, 3. First row is going to have, let's try to do the same, 4 cells. 1, 2, 3, and 4. So first cell is 1 per 2, split 1 per 2. It's going to be usable. Second cell, well, it should be much longer. So now let's just duplicate it. Well, local default container items. Remove this. Let's call it local debug cell 1 items. plug it here. Local debug cell1 items, plug it here. And also okay. Now let's duplicate it. Debug cell 2 items, 3, and 4. So I think that will not do second row. I think the 2 rows will be enough. 1, remove 2 rows. So that's first row, and it's first cell over row. It's not very comfortable to create it like this. Maybe let's create a function called debug create cell. Let it take 2 inputs like rows or just like dimensions of type int point. So what it's gonna do? It's gonna do the same as here, like this. Let's create local items of type bc container item array. Plug it here, plug it here. Split dimensions, x goes here, y goes here, x goes here, y goes here. And usable also gonna be a parameter. And we're gonna just return this cell. So now let's go back to our initialize function, and instead of doing this like this, we're gonna call debug create cell. First is gonna be 1, 2 usable. And how much cells? 4 cells. 1, 2, 4 cells for first row. This is gonna be first row. Make cells. Okay. Make array. 1, 2, 3, 4. So that's the first row. Now we have to remove array element pin, create a second row, and it will have 1, 2, 3 items. 1, 2, 3. Let's remove this one. 1, 2, 3 items. Okay. So first is going to be 1 to 1, 1 to 1, and 2 to 1. Debug pocket. So let's see how it will look like. Will it be even created? Yes, it is created, but we don't, as you can see, we don't have any spacings between our cells, and we have to add them, I think. So where do we have to add them? Here in the vertical box, we have cells created, but we should open container row, and in row we are adding a cell to a horizontal box, and after adding each cell to a horizontal box, we should also construct object from class and type in spacer here. Okay, and right after that we can get horizontal box and add child to horizontal box. And we're gonna add spacer, but first we're gonna set y. Let's check how parameter is called. Spacer size. So we're gonna set its size. Set size to 0 on y and let it be 2 on x and add it to horizontal box. Let's see, will it fix our problem? Well, a little bit spacing has appeared. So now let's increase size to 5 maybe, because it's hardly visible. Yes, now it's visible much better. But as we can see, here it looks a little bit prettier because it's centered. So we are creating a row, adding to vertical box, and let's set horizontal alignment to center. Yes, correct. So now, as you can see, they are centered and they look almost the same like here. The difference is in design. Oh, also, oh, that's problem. That's a problem. That's because we have a distance here. I didn't mention it. Select your vertical box here and check size to content. I forgot to do that, and that's why it didn't work correctly. So now everything works fine. And also let's add spacers to our vertical box the same way as we have added it for horizontal cells. So let's open our container graph and navigate to a place where it adds rows into a vertical box here. So now let's construct object from class spacer get vertical box rows and add child to vertical box. And it's gonna be a spacer, and let's set size to 0 on y, oh no, 0 on x and 5 on y, or how much we have set it here. 5.5, let it be just 5. So now paddings are applied and we see separation of our items. Now, for example, let me add much more apples like this and start game. Let's collect 1, 2, 3, 4. So it has added it to this pocket, but it doesn't add them to these pockets. So looks like something is not working here. So can add items to inventory. Well, for sure it doesn't work. Open function can add item to inventory. Add a branch here. plug result, and if it can add item to this container, then we're returning. If not, then we're continuing. And on completed, we're gonna return just with false result. So this function should look like this. Okay. Again, something is not working for these slots. Well, let's find out why. Again, we have a big problem here. So in function called hasPlace for item in container, we're checking if it found a place in cell, and if it didn't find a place in cell, then we're returning false, but we don't even check other cells. So unplug false and plug this to completed for rows, like this. Let's test it again, how it will look now. So everything, well. Let's make a little bit more apples. Well, as you can see, we have some small issues. I'm not sure if it is related to drawing, or we should debug it, by the way. So oh, 4, 1, 2. Mhm. So we're getting a dimensions, getting x, we're getting an index, and getting a module from dividing an index onto x, and this is our local x. Next, we're dividing an index onto x, not a module, just divide, and getting local y. So now everything works fine. And everything is added correctly into the needed slots. So we ensured that now our inventory works correct on different orientations, different slots, and so on. So what should we do now? Is I think it is a drag and drop functionality. So now let's open our VB container item, an item that we will drag, open event graph, functions, and let's override function called onKeyDown. OnKeyDown. Here we're gonna call detect drag if pressed. And it's gonna be left mouse button, and we are plugging return value here. And don't forget to detect drag if pressed. What? The current value pin is invalid. Oh, not on key down. Key down is for keyboard. I'm sorry. We should use on mouse down. On mouse. Where is it? On mouse button down. And here we're gonna detect drag if pressed. Plug it here, return value to return node value, and plug mouse event into pointer event. And drag key is gonna be left mouse button. Now we have to override on drag detected. So as soon as system will detect that we're trying to drag our inventory item with left mouse button, we have to do something with it. So let's create a new blueprint class, and it's gonna be drag and drag drop operation. Drag drop operation is something that is storing a data about what we are dragging. Let's call it BP, drag drop container item. Let's open it up. What it will have inventory system of type BPC special inventory system version 2. Instance editable, exposed on spawn. Compile, save. We can close it now and open our container item back. So on drag detected, we're gonna create drag and drop operation. And here select a class that we have created. It's gonna be BP drag drop container item. Now we have to plug an inventory system that about which our item doesn't know. We will fix it later, and plug item into, and also let's add an item to our drag and drop operation. So let's open it again and add item of type BC container item. Instance editable, exposed on spawn, and open container item. So let's refresh this node and plug item into item. Default drag visual is gonna be self, and that's all. And we can return it like this. So now, for example, if I will collect an apple, I will be able to drag it like this. Well, so now we can drag, but we cannot drop, and also we can't I don't know. We have to visualize somehow that we're dragging this object, because it's not understandable which object I am dragging right now. So let's close it, and on our container cell, oh, container item, I'm sorry. So on drag detected, let's on drag detected, let's for example get image thumbnail. Here, get image thumbnail and set opacity to, for example, 0.5, and on drag cancelled, we gonna get an image set and opacity back to 0, back to 1. Now let's take a look. So now we can define which object we're dragging, and when drag cancel, it is changed back to a normal visual representation. So now, when we have implemented drag functionality, we have to implement drop functionality also. So we have to define where can we drag an item. We can drag it into any other container. So not on a vertical box, and not on a row, but to another cell, VB container cell. So we can drag it onto different cells. So let's open our container cell widget and override function on drop. And here we gonna get our inventory component and call can no cell. Let's open a component. How this function is called? Has place for item in cell. So we also should not do it like this, I think, because for example, we can drag an item right to a cell here. Or for example, we can drag a magazine to this cell and we cannot edit here, but we also able to drag it onto an icon of this and of whole container, and it will edit to an empty space in this container if it is available. So now for cell we have to be able to check in runtime before drop whether we can drop an item into this cell. So let's open our VB container cell, and on drop will be empty for now, or maybe not. So for our cell, as soon as we have dragged our item somewhere in bounds of the cell, we have to be able to detect whether we can um, drop item here or not. So let's override the function called onDragOver, and here we gonna check it. So now let's create a sequence node. And what we're gonna do? We're gonna get a position of our mouse in context of a current cell to be able to know at which index we're looking. So for example, if our mouse here, we should know that we're looking at index 0 of this cell. Or if it is here, we should know that our mouse is above index 1 of this cell. So now I will use another files that I have created earlier because I don't remember how to get everything from here. So we are getting pointer event and getting screen space position. And screen space position of a mouse button is absolute, but we have to convert it into a local space of local cell. So we're converting absolute to local, and we have to provide at which space we want it to be converted. And this is a geometry of this cell. So we're plugging a geometry. So this is a mouse position. We're going to promote it to local mouse position. And well, what's happening here? Oh, understood. So we have to be able to define whether whether a dragged item is closer to a left side of a tile. For example, if our armor is, for example, if our magazine 2x2 is located here on the center of the square, we have to decide whether we should validate if it can be dropped on these two tiles or these two tiles and show it to a user respectively. So now we have to be able to convert a mouse position to understand whether we want to drop an item to the left or to the right. So what we're gonna do, we're gonna break mouse position, get an X, and modulate it by cell size. Next, we're gonna get Y and do the same. Next, if it is greater than the cell size, divide it by 2. Then we can promote it to a local variable called local right. Well, honestly, I'm not sure that I understand it 100%, so I'm sorry, but you can just repeat the process. So with these two values, we'll be able to define whether our item is closer to a right. If it is true, then it is closer to a right. If false, it is closer to a left side, and the same for vertical positions. So now we have an operation here, so let's get an operation and cast it to our operation. Cast to BP drag drop container item. And here we can get an item. From item we can get dimensions of our item and break them. We have to be able to find a top left index where we're trying to drop our item. So what we're gonna do, we're gonna get an X and subtract some value. We're gonna get a local right and select by local right. If local right is true, then we're subtracting 1. If false, we're subtracting 0. And we have to be able to clamp it, and so we're searching for a maximum between this value and 0. Next, we're doing the same for Y. But instead of local right, we're using local down. Next, we have to divide it by 2. And we can make int point from these two values. Make int point x, y. Right after that, we have to get our local mouse position and divide it by float cell size. split it. We're gonna cut decimal part of x and y. And we're gonna subtract one int point from another. We're gonna subtract it like this. And this is gonna be x and y of an index at which our item should appear. So now when we have this x and y in our cell, we can just promote it to a variable and call it drag top left position. And using this position, we will be able to count whether we can whether we can drop our item. So what we're gonna do next? We have to go to onPaint function here, and here we have a sequence. Well, we have a return node. Let's plug another sequence. This is gonna be first, this is gonna be second. And now we have to draw whether we can drop an item at the place where we are holding our mouse cursor. So, but we have to check if drag drop currently happening. So we're gonna check is drag dropping at the branch. So if drag drop is in progress, we have to draw our item. So we're gonna get drag drop content as it's currently happening, and we're gonna cast it to our BP drag and drop container item. Here it is. Here we're gonna get an item, and we have to get this inventory component from this container cell that it's, oh no, we have to get an inventory component and check if an item can be stored at this drag drop left position. So how can we do it? Do we have any functions for it? No, we don't have any functions. So we have to implement a function called can store item in cell at index. Can store item in cell at index. So what we're gonna do, we're gonna provide it with cell bc container cell and an index integer. So we have already implemented part of this function in function called has place for item in cell, and this is our logic. With local x and local y. So let's move a logic or a part of logic from this function back to this function can store item in cell at index. So local x and local y are gonna be an indexes, or maybe not an index, at location, and instead of index we'll have x, and we will also have y. So now let's open has place for item in cell and copy all top part, paste it here, and what we're gonna do? What we're gonna change? We don't need to loop through x's and y. We have to promote local valid to a local variable. We don't need local. Oh no, we need a local x, but it will be an x. So let's get x instead of local x, like this, and x goes here also. Item is we also have to add an input item because we don't know what item we're trying to store. It's gonna be bc container item. So let's compile. Where is item? Let's just get item again. A local y, instead of local y, we're gonna use get y. Copy it and paste it here for first index. Well, and and we have to return x and y. So we have to return y and we have to return x. On completed of this loop, in another case, if false, we're just returning false. Compile and save. So now when we have function can store item in select location, we can open has place for item, and we can remove this logic because we don't need it. We have local x, local y, and we can just call can store item in cell at location. We're gonna get cell x and get local y and get item also. So we're gonna check if the result is true, then we're just gonna return local x, local y, and return true. If result is false, then we're doing nothing. So it should work. Let's double check and try to collect apples. So everything is stored correctly. So now we can open our VB container cell again, and here in the function on paint, if is drag dropping, we're casting, and we can call can store item in cell at location. We can provide an item, we can provide a cell, And we can provide X and Y by using drag top left position. Get it, split it, X and Y. Now we can check a result. So if we can draw a box in the current context. We're gonna just get context for a context. And what about position? What about position? We're gonna get this X and multiply it by cell size, and it's gonna be position X. The same for Y. I'm gonna multiply it by cell size. And this is gonna be position Y. So X goes to X, Y goes to Y. Now what about size? Well, why do we need a brush? Well, what about size? Size is gonna be a dimensions of an object that we're trying to drag, of an item. So we're gonna get item. Oh no, or not. So we're gonna get an item first and get its dimensions. We're gonna get its dimensions and drag top left position X. We're gonna add drag top left position X to item X. No, that is this or no, that's correct. So we're gonna add them, and we have to validate that this size doesn't exceed the size of a cell by itself. Like if we're trying to drop two item onto a cell of dimensions 1 to 2. So how we're gonna do that? We're gonna get current position added to drag top left position, and from this we're gonna check whether it is bigger than okay, what do we have to do? We have to get the cell, get dimensions, and split it. So X is a width of a cell, and we have to check whether this width is smaller than this one. So what we're gonna do? We're gonna subtract an item dimension X from a cell dimension X. So after a subtraction, we can find a minimum between this value and dimension X. So this is going to be a valid X. Now we can multiply it on cell size, multiply, and this goes into size X. Now we're going to do the same for Y. So we're going to subtract and multiply it on a cell size, and this goes to Y. Now let's select tint color. So tint color is going to be, we're going to draw it in any case. So let's remove branch, and depending on the result, let's select a tint color. So if result is true, then we're drawing something like green color with opacity of 0.3, and in another case 0.3 but of a red color like this. So, well, looks like something that we have to check. and nothing is drawn or nothing is computed. So let's open our widget again, container cell, here it is, and we have to check whether our own drag over even called. So let's add the breakpoint here, add the breakpoint here, and test it again. Well, it is called. So, and yes, that's correct. Int point int 0, 1. So that's fine. Let's open on paint. Is drag dropping. Next. Okay, we're reaching this destination. And Dropbox. Dropbox is not working. Well, maybe that's because we didn't select the brush. So maybe we have to select it by default. I'm not sure. So let's open a folder and create slate brush. You can just type something here, or in the user interface you have slate brush. Let's call it VB default slate brush. Something like this. Open container cell and select it here. Whether do I need to change something here? I don't think so. So let's try it again. Okay, it's drawing something. Looks like on drag over is not. Or maybe it's called, but what? Why? It works very strange. So one more thing that we have to do is we have to create a variable in our container cell widget to define whether we dragged over this widget. So let's open on drag over function, and here I'm gonna remove my breakpoints. Here before returning we're gonna create a new variable and call it is dragged over of type boolean. By default it is false, and we're gonna set it to true here. And also we're gonna override on drag leaf, and here we're gonna set is drag over to false. Now let's open on paint function, and we can check here with is drag dropping. We're gonna check if is dragged over also true. So let's add end boolean and connect it to a branch. So what we have now, we have an apple, and we can drag it over is only this widget, and I don't know why, at least for now, nothing is displayed on the second widget. Also, why do I have two apples instead of one? Well, to fix this issue, in function on drag detected in our item, we have to remove from parent our items that we are dragging. So right after creating drag and drop operation, I am removing a widget from its parent. Well, now it will look like this. So, but also we have to make one fix. Also, I'm sorry it's a little bit late, and I make a lot of mistakes at this part. So here on paint function, we're calculating width and height of an item that we have to draw, and we're doing this incorrect. So what we have to use drag top left position X and Y. We need to use them. And we're gonna use get cell get dimensions. Let's split it. And now we're gonna subtract from drag top left position X from cell. So we will get how much distance till the end of a cell is left on X axis and the same for Y axis. Now, from this we have to find a minimum, min, and min for Y, for item dimensions. So we're gonna get an item here, get dimensions, just get item, get dimensions, split it, minimum between X and X, Y and Y, and after that we're gonna multiply both of them on cell size. And X goes to size X, Y goes to size Y. Compile, save, and let's test it out. So now, as you can see, every cell here is drawn correctly instead of first one. And that happens because in our inventory we have removed a widget from here, but in our inventory an item still appears here. And we will fix it in the next part. So thanks for watching, see you in the next videos.